Syria.
Thank you very much, Louise. Hello, everyone, and welcome to OTF Connect. Thank you for giving of your very own time to join us tonight. It's so wonderful to have such great representation from across the province, and good to have so many new participants here with us tonight. It is my pleasure tonight to welcome John Mighton from Jump Math, who will be facilitating the webinar, Introduction to Methods of Jump Math. John brings much experience and many, many ideas to share with us tonight. Welcome, John. I will pass the mic over to you now.
Thank you very much. I'm very honored to be talking to people tonight. It's a real thrill for us to join this series. So I'm going to give an overview of the methods used in Jump Math. And you're welcome to type questions in. Annie Churn, who's our Director of Social Media, will be following the questions. And I will try and adapt as I'm presenting to some of the questions, but I'll also leave some time at the end to answer questions. So I hope that works for you. So Jump is a charity. I'm a mathematician, but I struggled in math when I was young, and I felt very insecure about it. I almost failed calculus at university, and I didn't go into math until I was in my 30s. And so about 15 years ago, I wanted to help local kids. I wanted to do some volunteer work, and I didn't want kids to feel that they weren't capable of doing math. So I started Jump Math as a tutoring club in my apartment. So I'd love to know when we're starting out what grade divisions people are teaching tonight. If you could maybe send us some information about that. So I'm going to try, fortunately I think there's material tonight for a wide range of grades. So hopefully you'll see some examples from the grade level you're teaching. But also I think the methods that we're going to be discussing tonight are applicable across grades. So the other thing we'd like to know before we start is what your attitude is towards math and teaching math. So we put a little scale there that you can actually mark on and maybe place yourself, ranging from you're anxious about math to love it, and then along the teaching axis that you love teaching, or you may dread teaching math. It may not be your favorite subject. So you can be honest about that. There are a lot of people who are anxious about math through no fault of their own, and that's actually something I'm going to address tonight. I think that, you know, teachers are my heroes. They've driven the growth of the program. Teachers have volunteered for us. They've really helped Jump grow exponentially. But many teachers will admit that math isn't their favorite subject, or they haven't had time to learn it properly. And in Jump, we believe that just as we believe that every child can learn math, we believe every teacher can learn math deeply. And one of the reasons we wrote our teacher's guides is to help teachers learn the math as they teach it. There are two teachers in Vancouver. One of them was featured in the Vancouver Sun, who were very, very math phobic when they started teaching math. And after using Jump for several years, they began to love the subject and went on to do masters in math education. So we were very inspired by that. And I hope for the people who love math and feel great about teaching it, I hope you'll see some new things tonight too. The team of writers at Jump, we're all mathematicians or educators. We've got teachers one teacher who's actually taught in the Toronto School Board. We've got people who have PhDs in mathematics. And we've spent 10 years trying to figure out how to scaffold the math and how to explain it. So hopefully, even if you have a deep love of math, you'll get something out of this session. I saw, I'm just going to go back to that slide briefly. There's a real range here, and that's what we've really found in working with teachers. And I hope for the people who know the math and love it, that you'll see the depth of thought we put into scaffolding the math and explaining it. And I hope the people who are math phobic, we're actually going to do some math tonight, including some reasonably advanced problems, grade 6, 7 levels. But I'm hoping that I'll be able to explain it well enough that you understand it. So I wanted to start with a bit of data. This is a case study of a school in Toronto, the Mighton school, that used JUMP. A teacher, Mary Jane Moreau, tested her kids coming into grade 5 on the TOMA, which is a standardized test. And the red bell curve shows the marks at the beginning of grade 5. There was one girl as low as the 9th percentile, one student as high as the 74th percentile, and the average mark was in the 54th percentile. So that's very typical distribution of marks in grade 5. I don't know if people are seeing the same kind of distribution in your own classes, but in the scores of classrooms I've worked in and observed, that range is very typical. And people, I think, in our society have accepted that it's natural that there'll be differences between the strongest students and the weakest, very wide differences. So that as early as grade 5, you could have a 3 grade level difference between the lowest kids in your class and the top kids in your class. And I'm not sure if that's what you're seeing in your schools, but it seems to be universal. And I think as a society, we've accepted that. By grade 6, a lot of kids don't pass the EQIO exams, and that's a good predictor of long-term success. And by the end of high school, you can have a 10 grade level difference between the top and the bottom. So we think that's a serious problem, this belief that there are natural hierarchies. In fact, we think that the belief itself is one of the major problems teachers face in teaching math. And the question is it natural? And so Mary Jane followed the JUMP lesson plans, which I'm going to present tonight, very closely for a year. And when she retested her kids at the beginning of grade 6 on the TOMA, the average mark was in the 98th percentile, with the lowest mark in the 95th percentile. And then a year later, all the kids signed up for the Pythagoras math competition, and 14 of the 17 got awards of distinction. So that was quite a strong shift in grade 5, and grade 5 is pretty late to intervene. So, I think that's one indication of the kind of potential that's in children that we really need to start nurturing and tapping into. If a very average class with a wide range can within 2 years be doing very well in the Pythagoras, I think we've really got to ask why aren't we seeing this more generally? Now, JUMP has been involved in lots of other studies. This is just a small case study, but we've seen similar results in much more rigorous studies. So the most rigorous study we've been involved in is a randomized controlled trial in a Canadian school board. And in that trial, the JUMP students' knowledge grew at twice the rate of the students in the control group. So this was sort of a gold standard in research, and it's very rare to have that kind of validation for programs. One of JUMP's goals in education is to help raise standards of evidence in education. So that's why we're involved in so many studies, so that when teachers use programs, they know they've been validated in some kind of studies. We don't think it's fair for teachers to not have well-researched programs. So I wanted to ask you, and maybe you can type onto the screen, we've seen a lot of evidence in JUMP that kids have more potential than we typically see in schools. And I personally, as I said before, teachers are my heroes, and I think that teachers are really struggling to reach all their students and to close the gap. And I'd love to know from your perspective of what is it that makes it so difficult to teach math, and especially to close the gap between students. So if you want to take maybe a minute or two to type in some answers.
there. I've just put a timer up for folks there, and if you're having any trouble figuring out how to type on the whiteboard, there is a tool strip at the left-hand edge of your whiteboard space, and the fourth tool from the top is the text tool. Once you've selected that, you just click on the whiteboard and start typing. And not to worry if you're typing over top of someone else. I'm going to come along and shift things around for you.
All right, well, you really filled up the screen there. That's amazing, and I hope to get to most of those points. So I'm going to show you, we've surveyed teachers in training for many years now, and I'll show you what we found in the surveys, and there's quite a strong match between what you've written. So I'm going to just bring up that slide. So attitude of students and parents. Someone wrote in there that parents say, I wasn't good at math, so my kids can't possibly be good at math. A number of people wrote about the range of students in the classroom. And this is something we took very seriously in JUMP. If you remember the slide I showed earlier, in Mary Jane's class, there were kids as low as the 9th percentile and high as the 75th. And that would represent about a 2 or 3 grade level difference. And so we really designed the program to try and take account of that. And you saw that a year later, her kids were all much stronger, including her faster kids. Language, we tried to make sure that our materials minimized language in the student text, but that doesn't mean we don't expect deep communication by the end of the year. So there are lots of extra questions in the teacher's guide and the teacher's resource, but also the language gets denser and denser as you move through the 2 student books. I'll come back to that. We also hear from a lot of teachers that kids, as they get older, don't have the basic skills and concepts they need. And so you have to do a lot of review at the beginning of the year or through the year to make sure that kids catch up. And I'm going to talk about how to address that problem. People wrote about time and trying to get through everything. One of the things we found, and that Mary Jane found when she was teaching, is that if you have very well scaffolded lessons and you do a bit of confidence building at the beginning of the year and constantly start at the right place with students, then you actually cover more material in the year. Even though it seems like you're going a little slower at first, you get a momentum that allows you to cover more. And I'm going to work through some math today to try and show how that might be the case. Also, someone asked earlier in the chat about taking care of kids at a high level. You don't get the full conceptual depth of jump if you don't use the teacher's guide. And the teacher's guide lessons are online. They're accessible if you just go to our website and log in. I'll be walking through a lesson later. And the teacher's guide lessons have a lot of extension questions in them that take the math much further. And I'll demonstrate some of those later. Finally, a number of people mentioned that either they're not comfortable with math themselves or that they don't have time to think deeply about the math. And I saw this as a problem when I first started volunteering in classrooms, that even the most exceptional teachers often didn't have time to change the materials they were working with or scaffold lessons better. So I want to try and demonstrate what we've done to try and solve some of these problems by actually working through some math. Now, if you're interested in the program, you can go to the Jump Math website, which I see Louise has posted. And if you just log in and create a login name, you can access our teacher's guide lessons, which are really, these teacher's resources are really the core of the program. So I'm going to actually indicate those. So this set of resources here are all available if you just log in. All the lesson plans, the Blackline Masters, tests and quizzes and so on are available to you by just logging in, as well as the confidence building lessons here. And you can also register for workshops and webinars. You see those binders in the pictures are the teacher's guide lessons, and they will walk you through the math that I'm doing today. And in the front, there's a student book. Now, some people who are using the program think that the program is the student book. Because we're a small charity, you know, we don't have a lot of money for marketing. We're just getting the word out now through social media, through webinars and so on, that really the core resource in JUMP is the teacher's guide. The student book is not the program, and it is not a substitute for the lessons. You know, the worst way to use JUMP would be to throw the books in front of the kids and not teach a lesson. Now, the kids could learn something from the books because they're very well scaffolded and designed for students, but you'll be missing the heart of the program. The student book should only be used at the end of the lesson as a kind of, we changed the name to practice and assessment books. They're really used to assess whether the kids understand the lesson and to give them practice. In fact, we would recommend you don't give the student book until you're sure that the vast majority of the students can work independently. And then you can spend the time catching up any students who need the extra help. So at the end of the session, I'll answer any questions about the materials. We spent a long time making sure that our lessons are well aligned with the Ontario curriculum. So this is just a snapshot of a small section of our curriculum correlations. And in each of the lessons, you have a list of which correlations are matched. And also in the actual teacher's guide, you've got a list of the requirements and which lessons cover those requirements, as you can see down here at the bottom. Now that's just a small part of the correlation, so you can find that for every expectation. We call the method of JUMP guided discovery. There's new research in cognitive science that shows that if kids have to struggle too much, they can get overwhelmed, and that even though discovery is very important, it's important that kids figure things out for themselves and discover as much as possible. The new research is suggesting kids do best if the challenges are broken down into manageable steps. If there's immediate feedback and assessment, the kids shouldn't be left too long without assessment. First, because it helps them become confident and stay on task, and also because it helps the teacher see when they have to intervene and reteach something. The research is showing it's very important to scaffold lessons into sensible steps. That practice is far more important than people thought, and that it's important to differentiate instruction. Although we believe in JUMP that if you only differentiate instruction a little bit, and I'm going to show you how we do that, for the vast majority of students, that's enough to close the gap or to begin to close the gap. And if you differentiate too much and you tell some students they're just not in the able group or give them that impression, then kids' brains work less efficiently. There's research that shows as early as kindergarten, kids start comparing themselves to each other and deciding who's smart and who isn't in math. And once they've decided they're not in the talented group, their brains stop working efficiently. They stop engaging, remembering things. Eventually they become anxious and things get even worse for them. So we believe that by making all kids feel roughly equal, or that they can all do the same things, in other words, by not differentiating too much, you actually can close the gap much more efficiently than if you differentiate too much. And that's what Mary Jane found in that class. 4 of her students were on IEPs and were very, very low when they started. And as you saw, they were in the 95th percentile or above on the TOMA a year later. Now, I've written about this. I published an article in Scientific American Mind, which here is the name of the article. And because we're a charity, Scientific American Mind allowed us to put the link to that article on the JUMP homepage. So if you'd like to read about some of the new research on the principles of guided discovery, and I've given references to a number of articles from journals, very rigorous journals of cognitive science, then you can find it in that article. So I want to try and illustrate what scaffolding means in particular, how you could possibly teach all ends of the classroom, the stronger and the weaker students together, by actually looking at an EQAO question. So this is from an old EQAO test. It's a fairly challenging problem for students. And I think I think when JUMP started, you know, we had very limited resources and we produced some worksheets for students, and people got the impression that was the entire program. But we've spent years writing teacher's guides that were built around the EQAOs. So I'm actually going to show you where this question features in our books. We were very careful to try and figure out what kind of problem-solving skills and knowledge kids would need to do well on the EQAO, and those are embedded in our grade 6 teacher's guides and our grade 3 teacher's guides. So I'd like to walk through this problem. If you want to take a look at it, there's 2 towns. The ratio of girls to boys is 4 to 5 in one town, and there's 36 kids. And then in another town, there's 40% girls and 45 kids. And the question was, which town has more girls? So I normally, if we do this question in training, people work together. But if you wouldn't mind thinking about that for a moment. And I think today we're only going to look at town A, because we don't have a lot of time. But I want you to think about, first of all, how many girls are in town A? How did you find the answer? Can you do it in more than one way? Are there easier approaches to this problem? Where do you think students would struggle or be confused or make a mistake in town A? So I'll maybe give you a minute to think about that, and just sort of maybe you could write your answer in the chat of what your answer is to the number of girls. If you want to write an observation on how you did it, that would be great too. So I'm noticing a couple questions. This is a grade 6 EQAO question, yes. If you have any questions, this is a good time to send them while people are thinking. Now, if you want a little bonus question, because we always give bonus questions in JUMP, you could think about town B, and I'll give you a challenge for town B. Quite often people would solve town B by just doing a calculation. They would do, for instance, 0.40 times 45. Now that will give you the right answer for town B. But can you come up with a simpler way of doing it? For instance, could you take the information about town B and turn it, there you have a percent, could you turn that into a ratio, just as in town A? Could you give me a ratio of girls to boys, and could you solve the problem that way, rather than doing a percent calculation? because a lot of people have trouble explaining why in the world you're doing this multiplication. And that's very, very clearly explained in our jump books and Scaffolded. But I think if you just tell a student multiply by 0.40, they don't have a clue why. It's just a mystery. And one of our goals in jump is to dispel the mystery of math and to make it clear that it's actually a much easier subject than people think. Someone says I use 10% first, and that's a very good approach to that town. Now I'm gonna go on to town A, and I'm sorry that I don't have time to look at town B in any depth, but I would recommend you look at the grade 6 resources, the teacher's guides that are online if you want to see a full treatment of that. Now I'm actually going to explain. I'm going to give you a difficult explanation of town A. Of my solutions to it, and I want to see if you follow it and understand it, because I want to illustrate how a lot of math teaching happens. So here's my explanation. There are 36 kids, so I think there's these zeros here got here by mistake, so they don't mean anything. There's 36 kids, ratio of girls to boys is 4 to 5. So I'm going to now show you a solution. So first, I know this ratio here is 4 to 4 and 5, so I'd add those and I'd get 9. Then I would divide 36 by 9 and I get 4. Then I would take each term of the ratio and multiply it by 4. And lo and behold, I get the answers 16 and 20. So I wonder how many people understood my explanation, and or how many people didn't understand the explanation or felt I went too fast and that there were too many things involved in my explanation. Would you be able to explain what I just did to a student? Would you be able to explain to a student why you added 4 plus 5 to get 9? Why you did this step? Now someone said that's what I did, so that's a very sophisticated, this is a very sophisticated way of solving the problem. The question is, would you be able to tell a weak student or someone who wasn't very strong at math what all those steps meant and why they worked? Because I've had many people in training who did it this way. They were very clever and very smart at math, but they weren't absolutely sure why they did some of these things. It just came to them. They just knew that it was the right thing. Maybe if someone wants to put some X, someone put an X here, which is good. If people didn't understand my explanation or wouldn't be able to explain it readily, you could put some X's there if there's anyone who feels that. Someone wrote in the chat that they thought that explanation might be complicated for kids. I think there's a lot in it. So I want to ask also, before I gave that explanation, I mean, did most people try and do a calculation, or did anyone try and take a simpler approach? Did anyone try and draw a diagram, or just try and draw a model of the town? So maybe if anyone did a model of the town, maybe you could put a check mark on the page for me if you tried to actually draw the town. So what I'm going to do is, in JUMP, because we're all mathematicians, we've spent years thinking about the math, and we always try and start by thinking of the simplest possible explanation, because I think that unless you can explain things in the simplest way, you may not really deeply understand the more complex explanations, like the one I just gave here. In fact, logicians proved 100 years ago that all math can be reduced to very simple steps. And I think quite often kids don't have the benefit of being shown those simple explanations. So I'm going to try a different approach. I could just start drawing the town where each circle represents a girl and each X represents a boy. So I could put them in rows like this and then eventually draw the whole town. So I'm not sure if anyone tried it that way, but I would just keep putting down 4 girls and 5 boys and 4 girls and 5 boys, and I'd stop when I got 36 kids. Now, a slightly more sophisticated way that I've seen teachers do is to make a T-table and to just add up the number of girls and boys. So here there's 4 girls, and that appears in the chart there, and 5 boys, and that appears in the chart there. And then you could just keep adding until you get the total. And the solution would be 16 girls and 20 boys. So that's a simple way to do it. Now, I've seen some teachers do something more sophisticated. They put a column here and made a little table, and they put the total. So they would just add up the total, and then they would keep going until they got 36. So down here they would get 36. So those are both basically the same method. This is a little simpler, the one with the picture. But it's surprising how few adults actually draw a picture, and how few teachers will draw a picture in our training sessions. Quite often they'll either use the method I just told you, or they'll make a fraction, which I'm going to come back to later. Now, I believe that I struggled in math and went on to be a mathematician, but I don't think I understand anything in math until I can take it back to the simplest explanation, and that's what we've tried to do in our teacher's guide lessons. So I'm going to come back now to the complicated lesson, this one here. This was a complicated explanation, and try and connect it to this picture. So let's look at the first step. There were 4 girls for every 5 boys, and I added those and got 9. Where do you see 9 in this picture here? Where would you see the 9? Yeah, in one row. So someone just answered in the chat. It's basically a row. A teacher once said that she thought of putting the kids in teams, 4 girls and 5 boys, and so it would basically be a team. So there you can see the 9. This 9 here comes from thinking of the girls and boys as a group. Now, why would I divide 36 by 9? What is that going to tell me about this picture? What's this 4 mean that I get? Where do you see, once you take the number of kids, so 9 is this number here is the number of kids on a team or in a group. And then you divide the number in a group by 36, and 4 gives you, and someone has written the number of rows or the number of teams. Yeah, exactly. There would be 4 of these rows. So you've got 9 kids in a group. And when you divide 36 by that, the 4 is the number of groups. This 4 is the number of groups altogether. 1, 2, 3, 4. Now, one thing that's unfortunate about these numbers, there's 2 4s in this problem. There's a 4 here, and there's a 4 here. And they both mean completely different things. This 4 up here is the number of girls in a group. And this 4 down here is the number of groups. Now, if I was teaching this lesson, I would change one of those numbers. I'd change the numbers slightly so these didn't match each other. Because if a child's looking out the window or distracted and they come back, they might completely miss the fact that those 4s mean totally different things. So now that I've divided 36, which is a total, by 4, I found out there's 4 teams. And that's why I do this multiplication at the end, or 4 groups. Because I've got 4 girls, and I've got 4 groups of them. So that gives me the 16. And I've got 5 boys, and I've got 4 groups of them. So that gives me the 20. So that connects that more complicated explanation back to a simple picture. So I'm just going to take a look at the chat for a minute. Yeah, so people's answers were very clear. People said that the 9 tells you how many are in a group, and that the division of 36 by 9 tells you how many groups of 9 there are altogether. So all of this is very clearly explained in our lesson on ratios, and I'm going to come back to that lesson later. But we try to show and jump multiple approaches to the problem, but we always try and root it back to a very simple diagram or explanation so that you can see where all the steps happen in the diagram. Now, another important feature of our lessons is review. In our grade 5 book, the books that Mary Jane used to shift the bell curve in her class, our early lessons are very simple. We don't even assume the kids can really add or subtract very fluently coming into grade 5. And we found that by embedding review into the lesson, you can close the gap very quickly. And not only does it help the students who are initially weaker, but it actually changes the atmosphere in the classroom. If you start the lesson at the right level, and you allow all kids to feel they can participate, then even the fastest kids benefit because the whole class goes further and the whole class gets excited about mathematics. So we once filmed a lesson in Parkdale in Toronto on perimeter, and these were the two problems that I wanted to get to on this page. One was I wanted the kids to be able to find the missing sides in a rectangle if they were given the perimeter, so this is this first problem. And then the other thing we wanted them to solve is more complicated problems where they had missing sides in a complex shape. Now the class that I taught was grade 6, but there were kids at about a grade 3 or 4 level, and I was very surprised when I started the class. I wanted to do a bit of a review, and so one of the first things I started with was just asking them to find the perimeter of a simple shape like that. And I was pretty surprised when a number of the students, almost 20% of the class, had trouble even finding the perimeter of the shape. Even though I asked them to write the lengths of the sides on, like that would be a side of length 2, because there are 2 edges. But even though I asked the kids to do that, there was still about 20% of the class that made mistakes on simple shapes like that. Now, the reason they made a mistake is because they tended to miss sides when they were counting. So I'd love to know, where do you think they would miss a side in that shape if they were trying to count all the sides there? So all the edges, like this is 1 edge, 2 edges, 3, 4. Where do you think they might miss an edge? Now someone, if they want, can you can either type in the chat, or you can, yes, exactly, that edge. Any other edge they might miss? That's one of the ones, yes, exactly. Those I found in teaching as many times that kids will miss one of those 2 edges. I guess because they're in a corner. And in fact, even if they write the side length on one of them, they often think they've labeled both of them. They don't notice that they've actually got to label both of them as one. So I was fortunate that I gave that little warm-up exercise in the class, because if I hadn't caught that early, almost 20% of the class would probably be struggling by the end of the lesson. And that shows the importance of review. I suspected that there were some very weak students in the class, and before I moved on to the more complicated shapes that I showed you earlier, I wanted to make sure that they could deal with simple shapes. Now, you might think, well, that's going to be very boring for the faster kids if they have to wait while you're marking that. So I immediately gave some bonus questions. So for instance, I asked the kids first to draw a letter of their name or to make a shape, and kids love doing that. They make very complex shapes and find the perimeter. But then I also gave some more complicated challenges. So for instance, I said, suppose you add a square to this, so it's joined onto one of the edges. Now the original perimeter of the shape is 8. And if you add a square, you could ask kids to predict what's going to happen to the perimeter. Many kids will predict that the perimeter is going to go up by 3 because there's 3 new edges added. But is that really what happens to the perimeter? It only goes up by 2 because you're actually covering up an edge. So I gave the kids a challenge to try and add a square to that shape and place it so that the perimeter stays the same. And you could see, we videotaped this class, and you could see the excitement goes up immediately because the kids have a puzzle. And I found universally, I've taught in very severe behavioral classes, I've taught in gifted classes, but universally kids love it when you actually raise the bar incrementally in a lesson and make the challenges harder and harder, but only incrementally. There's a famous psychologist, Carol Dweck, who showed that it's very important for kids to have a growth mindset. If kids think that they can only succeed in math because they inherited some kind of gift or they have a natural talent, they do worse over time than kids who think that their success depends on hard work and perseverance. Those are the kids with a growth mindset. So Carol Dweck watched that video, and there's a video of her on our website talking about how keeping kids in a zone where they're always doing things that look hard but succeeding would really help them develop a growth mindset. So we think of Jump That Math as an ideal tool for actually making kids confident, making them feel they can persevere and solve any challenge. But if the challenges are too hard and they're not scaffolded well, then you get typical classrooms where only the top 30 to 50% really want to engage in the problems. If you keep kids in a zone where they're always at the edge of their capacity and feeling that they can always meet the next challenge, then they really develop a growth mindset, and we found over time they start to learn more and more efficiently. So that's an example of a bonus question or an extension question you could give faster kids. So that would give you the time to check the few kids who are missing these sides, that don't see all the sides. Now, in this lesson, I got another surprise as I was teaching it. So I wanted kids to eventually solve problems about rectangles, so I asked them to draw all the rectangles of perimeter 12 that they could. So for instance, here's an example. If you make this side 1 and this side 5, that has perimeter 12. But I was very surprised because about 20% of the class, again, started making mistakes. So here's a typical mistake kids will make if you ask them to draw a rectangle of perimeter 12. They'll make this side 1 long, and then they'll make this 11, and they just run out of perimeter. They're done. Or they mistake it with area, in which case they do this. So in this class, I actually had to draw sides for kids and then have them, they had grid paper, so they had to guess and check until they completed the figure and found what made 12. And I don't think if I had done that review and spent that bit of time having them explore that they would have eventually got to the harder questions where they were finding missing sides. But the interesting thing is that with those two pieces of review, so just reviewing what it means to see all the sides of a rectangle, to count them, of a shape, I mean, and to count them, and then understanding how the perimeter wraps around a figure, that you just don't run out of perimeter, that you have to make it wrap around. Just from those two bits of scaffolding and review, by the end of the lesson, the kids were able to do those much harder problems that I showed you earlier. So I'm just going to go back to those. So the entire class had a great deal of success with both these types of problems, and it was only about a 45-minute lesson. So I think that shows the importance of review, and that you can actually cover way more in a class if you make sure you close the gap between kids and give every kid in the class the tools they need to succeed. Now in mathematics, the wonderful thing is usually in most lessons, even up to a grade 6-7 lesson, there are only a few things you need to review and make sure the kids know before they can start to engage. That's not always true, but for the vast majority of lessons. Okay, so now I'm going to come back to the towns problem again. It's a very rich problem, and talk about the idea of scaffolding and give you an idea of what we mean by that. So some people, and especially teachers in our training, will solve this problem by making a fraction. They'll try and find the fraction of girls. So if you remember, there's 4 girls for every 5 boys. If you ask the student to make a fraction of girls, what do you think is the most common error that they would make? Now, you're welcome to type that on the screen or to put it in the chat. Yeah, thank you. Someone's writing that in, and it's exactly the error. Oh, 4 over 3, that's good. 4 over 36, good. That happens. There's an even more common error if you focus on the ratio. What's the other one they make? Yep. Yeah, I know 5 is hard to draw. I'm having trouble with it too. Yeah, so exactly. Those are the 2 most common errors. And you know, I keep saying teachers are my heroes. JUMP would not exist without teachers. They've driven the growth of the program. They've taught us. But quite often I see teachers make this mistake in training. And in fact, they sometimes write a more sophisticated answer that's also wrong. They'll say 80% because 4/5 is 80%. Now, I think that really shows how, as adults, we often just guess at math, and we just try and find a number or use a formula without really understanding it, because 80% is well over a half, but the number of girls is under a half. I mean, if you compare 4 to 5, then clearly there's not even half of those kids are girls. So 80%, to anyone who even thought about the question, couldn't possibly be right. And that shows the depth of our anxiety about math, because people often just want to guess the answer. So I'm going to show what we do in JUMP to try and deal with this problem. I've looked at many grade 6, 7, 8 programs and books, and it's very rare for those books to sort of treat the part and the whole in any depth before they launch into percent problems, ratio problems, and so on. The correct answer here is 4/5. There's 4/9 girls. And if I ask you about the mistake, like what was the mistake in this case here? Where was the mistake? Why was 5 incorrect? It's because when you're trying to make a fraction, 9 is the correct answer because you really wanted the whole on the bottom and the part on the top. Whereas this here, this is a part to a part ratio or fraction. And so when you're trying to find the fraction of girls, you want the part to the whole, as in this case. Now, in order to sort of help kids get over that guessing instinct, we have a lesson in our grade 6 book that starts something like this. Suppose you have 4 girls in a class and 11 kids. Can someone write in on the screen, in this case, what fraction of the children would be girls in this first case? So here, what fraction would be girls? You could write it over here in the column if you'd write it over here. So 4 girls, 11 kids, what fraction are girls of those children? Someone's written it in the chat, so yeah, 4. 4/11, yay, yep. Okay, people are filling in the whole thing. All right, so I'm gonna write in here 4/11, so everyone can see clearly. In the second one, 7 over what? 7/13, that's right. And in the last one's a bit of a trick question, but no one fell for the trick here. The correct answer is 7/10. That's right. Now, could we clear that screen for a sec? Louise, would you mind clearing it? And I'll just write in the answer. So the first one was, thank you for providing those. The first one was 4/11. Hope I don't make a mistake here. 7/13, and the trick question, 7/10. So in the first question, these two pieces of information, if you want to use the words part and the whole, what am I given in the first question in terms of the part and the whole? What is girls? Yep, someone's written that would be the part. So that's the part, and what is 11? That's the whole number. In the second example, it's a different case. Now we have what are the two pieces of information? The part, yeah, someone's written the part and the part. That's right. And the last one, I mean, it's a bit of a trick question. Again, we have a part, but it's the wrong part. We could call it the wrong part because it's not the actual number that you're using in the fraction, and then we have the whole. Now, if you have a whole that's divided into 2 parts and you have a question about it, those are really the only 3 possibilities, the only 3 ways I can give you 2 pieces of information. I mean, I could ask about the difference, but in a typical percent problem or fraction problem, these would be the 3 cases. 1, 2, 3 would be the 3 types. Now, there's nothing very deep there or difficult, but if you don't assess that before kids start into percent problems or ratio problems, then probably the lower part of the class is going to struggle. So I'll show you what kind of scaffolding we provide in JUMP. So this is a snapshot of one of the student pages. You'll notice question 1. What do you notice about question 1 that might be different from a typical textbook or approach to this? If you just look at question 1 here, is there anything that strikes you about the design of that question? Yeah, so one thing someone asked about is, see that code up in there? That means number sense grade 6. The NS6 is number sense grade 6, and then 108 is just a lesson number. So this is a student page. This is a page from our student assessment and practice books. Okay, so I'm reading the chat. And it says includes both the part and the whole. Lots of practice. Someone said this is great. That's very nice. Yeah, it's fast. That's a good point. Kids can have easy success with this. What about the language? What do you notice about the language in this question? Because someone said earlier, several people said that their kids struggled with the language in mathematics. Yeah, the language is simple and clear and repetitive. You'll notice we never change the wording. It's always boys and girls. So what advantages does that have? Well, first of all, you're going to have very few kids in your class who can't read that. Secondly, if you have a kid who can't read it and you've showed them how to read one sentence, they're likely to be able to read the rest. You're just going to have to intervene once. So also, you'll notice that they have to write the answer for every single question. They can do it very, very quickly. But we did this to rather than just asking them about one piece of information, we asked them to provide every piece of information for every class, because that stops them from guessing. If they have a picture of the entire question all the time, the entire situation, then they're not going to guess anymore. They're always going to form a picture of the part, the whole, and think of the parts as making a whole. Now you'll notice in question 2, there's a small variation. So now not only do they have to write the boys, girls, and children, but now they have to write in the fraction. We're working with Professor Brent Davis at the University of Calgary. Jump model schools have been set up in the Calgary board, and the researchers from the University of Calgary are observing the teachers and students, and they're finding a real correlation between fidelity of use of the JUMP program and improvements in student scores. And Brent and his team are experts in something called variation theory. There's a lot of evidence in math education that kids do best if you vary only one element of a problem at a time, and then you start to vary different elements simultaneously. And that's what we stumbled upon naturally in just working in classrooms and seeing that we could close the gap by applying variation theory, even though we didn't know what it was called. So here's the next part of the page. This is a continuation of the same page. And you'll notice in question 3, we've removed the scaffold of the writing in the number of boys, girls, and children. We assume they've got that now, and then they'll have to go mentally straight to the fraction. At the bottom of the page, now this last question depends on some teaching from the teacher's guide. In these questions, the kids will have been introduced to ratio. You'll notice there's a ratio problem there. They'll have seen that earlier in earlier lessons, so they can do that. But definitely this is a harder question on the page, and you can see the movement now to a harder type of question. But this work is prepared in the teacher's guide. The kids will have practiced questions like this even before they attempt this page. Now that's one page. This is blown up, but that's just one page in the jump book. So you can imagine that that kind of scaffolding can take literally 10 minutes. But the difference is enormous. This is the second page of the lesson, and there you can see the EQAO style problems and then more sophisticated problems on that page. And you can imagine that you would have to do less work as a teacher to catch the kids who are struggling if you'd done that prep page first. Yeah, sorry about the binary gender. We wrote these a while ago, so we're actually revising our books, and we'll probably take account of things like that. But that's a very good point. Okay, so I'm going to move on now. To the idea of practice. So so far I've talked about the importance of review and how important it is to embed review in your lesson. And that review doesn't have to take a long time. In the lesson about perimeter, there were really only 2 things I had to make sure the students knew. I talked about scaffolding and how to break challenges into more manageable steps. And you can see we also think a lot about minimizing extraneous information. There's a lot of new research that shows that extraneous information in questions, that means overly complex diagrams, too much information, has a very detrimental effect on students. It leads to what cognitive scientists call cognitive overload. So that's why those pages were so spare and the language was so simple. Now, people confuse extraneous information with conceptual depth. It's pretty clear from the kind of typical scores in classrooms that putting lots of extraneous information into programs does not lead to deeper conceptual understanding on the part of most students. In fact, we believe that the extraneous information obscures the big ideas. If you think back to the question we just looked at, there's no hidden depth, there's no yawning conceptual depth that makes the question possible. If you understand what the parts are in the whole, you can solve the question. But unfortunately, all the extraneous information and challenges and tasks get in the way of seeing the big idea. And we try and surface the big ideas and jump in a way that all kids can see. Now, one thing that gets in the way also of seeing the big ideas is a lack of basic skills and concepts. New research is showing that if you don't know, if you don't have basic knowledge in a kind of automatic way, for instance, if you don't know your times tables or your number facts, then your working memory is constantly overwhelmed trying to remember these things. We have very poor working memories. We can only hold a very small amount of data in our working memories. And if you haven't committed the facts to long-term memory, you're always at a disadvantage as a student. Not only that, if you don't know relations between numbers and know the facts, you'll have trouble seeing patterns or making predictions or generalizations. Now, many people think that the only way you can teach basic facts is through this horrible method of drill and kill. And there's a famous cognitive scientist, Herb Simon, who said that calling practice drill and kill has done a great disservice to teachers because all of the evidence on how people become experts at things shows that practice is one of the most important features. And Herb Simon said the instructional challenge is how do you make practice interesting? You don't want to avoid practice, but you can structure it in a way so it's not drill and kill. The two things are not synonymous. Practice does not have to mean drill and kill. So here's an example, for instance, with the 3 times table of how you could get kids to practice writing out the 3 times table and remembering it without being bored. So first, ask your kids to write the first 3 multiples of 3, 3, 6, 9 in a row. And then they could continue, but write the next 3 multiples underneath and the next 3 multiples underneath. And you could even add a 0 in the ones digit just to make things clearer. Now, then you ask your kids, I've done this with grade 3 students and it works like magic. You ask the kids to look for any patterns in that chart. Now, you can guide them more or less depending on your taste. You could say look for patterns in the columns. So, for instance, you could look at the 1s and ask them if they see any patterns in the 1s. So, do you see any patterns in the 1s there? Then you could also ask them to look at the 10s. Yeah, the 1s, there's many ways to look at the 1s. They go down by 1, but you're always subtracting 1, or you go up by 1. So with the 1s, you're subtracting 1. With the 10s, you're always going 0, 1, 2. Now, a lot of people will see other patterns. If you add the digits, you get 3 in the first column, 6 in the second, and 9 in the last column. Fortunately, there are lots of great patterns there for kids to explore. So that gives you lots of time to make sure every kid gets the basic patterns. Now, thank you for writing that. You'll see that someone has written on the screen that the 1s are always increasing if you go from the bottom, and they're increasing if you go from the top. So now, Louise, would you mind clearing that screen because I just want to feature something. So once kids have explored that, there's only 2 things I'd like them to see. I'd like them to see the pattern in the 1s column and the pattern in the 10s column. If they can articulate that, then I rub out the chart and I only put the first 3 numbers in, and I'll ask them to recreate the chart using the patterns they discovered. In fact, quite often I'll name the patterns after the kids who discovered them. They absolutely love that. But if you basically eliminate the bottom part of the chart and just give them the top part, then I found that within 5 minutes or so, every kid in the grade 3 class can write out that chart using those patterns. I tried this with a grade 3 class once, and they absolutely loved it. And I thought they'd get through one chart like this, but they ended up exploring about 6 charts by the end of the lesson. I'll show you some other charts later. Now, once they've memorized that chart and can write it out without thinking, now this could take, you could give that for homework, they could go practice it at home, but once they have that automatically, the next step is this. You could tell them to think of the numbers as like the numbers on a phone pad. This number is in position 1 on a phone pad. This is in position 2, 3, and so on. And you can cover up parts of the chart and ask them what number was in position 3, for instance, or cover up the lower line and say what number is in position 8. And when they can say that automatically, then they know their 3 times table. Because, for instance, suppose they know what numbers in position 6 is 18. Well, 3 times 6, remember this is a 3 times table here, so 3 times 6 is 18. And it's right in the chart. All they have to do is be able to know the position of the numbers. Yeah, someone wrote, there's fantastic comments in the chat, and I'm sorry I can't keep up with them all, but someone said this would be great to do at a center once they know it. Primary kids could drill each other. The phone pad idea is great. I've used this with a number of kids now. I only started taking this approach recently, but I've used it with a number of kids, and it's amazing how quickly they memorize that chart. And then they know their 3 times table. And there is so much evidence now that kids who know their facts automatically have a huge advantage. So that's an idea. Now, it turns out that if you put other odd numbers in rows of 3, like the multiples of 7, you'll also see some great patterns that make it very easy to remember. And if you put the even numbers, in rows of 5, so that's 2, 4, 6, and 8. Put the multiples in rows of 5, you'll see other amazing patterns. Now, if you'd like to see a treatment of this, I did a TEDx talk that's recorded, and it's on the homepage of our website. And I go through all the patterns and all the one-digit numbers on that TEDx talk. So you can go to our website at Jump Math and look at it there. I'm sorry I don't have time to cover the others. But with this grade 3 class, I was just amazed. Some of the kids hugged me afterwards. I found out later it was a grade 2-3 split. So the kids had no trouble finding these patterns